Welcome to the Daily Space Weather. Congratulations on realizing our channel exists. We hope these videos will continue to exist. Let's just say the likelihood has not increased in the past month. Let's take a look at the sun. We've got 6 sunspot groups at the moment. One of them is quite large. It's this one down here. Likelihood of major solar flares is quite high. Let's take a look at some more imagery here. That's ionized helium. How about a little bit of ionized iron from the SDO? And we'll also break out the colorized magnetogram. Certainly this sunspot in the northwest is looking ripe for a flare, a major flare. You see the umbra spreading apart here and not shrinking. Anyway, there's a great analysis of the evolution of these sunspots. Colorized magnetogram, one of the best products from the Solar Dynamics Observatory. So quite an active sun here compared to what we've been seeing recently. The sunspot number went all the way up to over 120 for a brief moment. Now it's going to go right back up to around that same level. We did see some C-class flares out of both this active region and this one. I haven't memorized the numbers. I don't care what they're called. It's essentially arbitrary. Sunspot numbers are just a list. And at least one of those sunspots has returned. The radio flux has returned to 85 solar flux units. Here's a one-year chart of that. The black line's the radio flux. The red line's a sunspot number. Here's a space weather enthusiast dashboard showing a brief period of geomagnetic unrest forecasted for tomorrow. Summer's over, folks. You've only got a few hours left. As the equinox happens today, the equinox, the moment that the Earth's equator crosses the sun's. Seismicity over the past 90 days, there's a bar graph for it, and the current level is high. Largest quake of the past 24 was this 6.4 off the coast of Chile. A 6.4 magnitude earthquake there. We also saw a 5.9 in Australia. Shout out to Kimberly. Thanks for giving me a heads up. So a couple of 5s there at the bottom of the list near Easter Island and Izu Island near Japan. That 6.4 at Chile occurred at 13:14 Universal Time yesterday on September 21st. Continuing up the list. There was a 5.0 at the Philippines. And if there's anything that we've left out that you'd like on the list, please leave us a comment. So this 5.9 occurred in Australia here at 23:15 Universal Time. Just 45 minutes before midnight. It did cause some damage from what I heard. And shout out to our viewers from southeastern Australia. Panama saw 5.2. So a bit of an earthquake uptick there. We also see an uptick continuing here at La Palma. That lava fountaining there is from Cumbre Vieja volcano. And we've seen additional fissures opening up here as the lava makes its way toward the coast. So La Palma showing impressive lava fountaining. And we're over 6,000 people evacuated at the moment, pushing 200 buildings destroyed. Karimsky on the Kamchatka Peninsula also erupting. Flight level 080, it's produced an 8,000-foot plume of volcanic ash. Suwanosejima exploded. Similar ash plume there, 8,000 foot over the Ryukyu Islands. Semeru producing a 13,000-foot ash plume over the Indonesian Isle of East Java. Samisa Pochnoi, periodic emissions and explosions are enough to produce a 12,000-foot ash plume over the Aleutian Islands. Popocatépetl back on the list as it explodes, 19,000-foot ash plume over central Mexico. Revenador exploding, 15,000-foot ash plume over Ecuador. Sabancaya, volcanic ash not identifiable in satellite imagery. Please don't assume that it's not erupting and decide to pole vault the caldera, please don't pole vault the caldera. Please do visit our links and support the channel, as the likelihood of these videos continuing to exist goes down and down and down, especially in terms of YouTube. Yes, I won't harp on it or complain about it much besides stating that these videos could go away at any moment. So please support us. So our largest month ever on YouTube has been the past 30 days. We've gained over 150 subscribers and about 5 times as many views as we've seen in previous months. Guess what our revenue is, folks? 0. It's exactly 0. Follow us on Instagram if you'd like to see more information like that. But most importantly, follow us at smashomash.com/smashteam, the real source of our content. And if it comes down from YouTube, the videos will continue to exist. They'll just be elsewhere because the platform, frankly, sucks. Next, looking at the GOES magnetometer here over the past 3 days, we saw a coronal hole wind stream show up last night, causing a brief period of geomagnetic unrest. And we've got some plasma moments here. Causing some sawtooth patterns there on the GOES magnetometers. A recent spike happening here in magnetism there, as measured by both the GOES 16 and 17. Those are the red and blue lines you see on the GOES magnetometer. Let's look at the current sheet, the heliospheric current sheet. And Earth remains in a South Pole-oriented one. There's the latest image. South Pole current sheet shown in red, North Pole current sheet shown in green. Here's a line-of-sight view of the same data. It's from 51 ground-based magnetometers and magnetometers on stereo A and stereo B. It's the National Sunspot Observatory. And it's one of the most important pieces of data we have in terms of monitoring solar activity. Here's a coronal hole line-of-sight plot showing the sun's B field in blue, coronal holes in red or green, depending on if they are South or North Pole oriented, respectively. Large South Pole oriented coronal hole just rotating through the Earth-facing zone here. So here's a 48-hour video in 193 angstroms from the SDO showing a great view of that large Earth-facing coronal hole. Going to produce some geo-effective plasma effects here. I don't know why it stopped playing. It froze. Anyway, moving on to the flare monitor, the likelihood of major solar flares is certainly there, especially out of these two sunspot groups, 2873 and 2871. 2871, the most complex of all. I think it might have degraded a little bit, but it's mostly been stable since yesterday. So, coronal solar flare watch, in effect. We're just this side of a solar flare warning, in my opinion. So, here's a 1600 and 1700 angstroms SDO view of the closest star here. That's ionized carbon and just extreme UV. And we'll show you a close-up of the northern and southern hemispheres. Great view of the north there. And you can see those umbrae of that sunspot. 2873 was it, is about the size of Earth. Some large umbrae there. Looks like they may have degraded a little bit over the past 24 hours, the length of this video. And it looks like 2871 has largely been stable here over the past 24. So you can see 3 C-class flares here over the past 24 hours. Again, likelihood of additional flares remains. No spikes in the proton flux there. No relativistic particles have been striking the geospace. Let's take a look at the solar wind as measured at Lagrange point 1 by the ACE and Discover spacecraft. We see a subsiding of the coronal hole wind stream here. Not even making it to 400 kilometers per second. It's pretty slow so far. And again, we can expect a much more significant coronal hole wind stream in about 3 days from that large, well-defined South Pole-oriented coronal hole we showed a minute ago. Current conditions are just around 6 protons per cubic centimeter for the solar wind density, solar wind speed 387 kilometers per second. And if I had to guess, I would say the coronal hole wind, this little minor coronal hole wind stream here is subsiding. The solar wind density only reached to about 35 protons per cubic centimeter with that. And the geomagnetic unrest was largely caused by this powerful BZ component around the same moment that the density wave showed up. As soon as that subsided, the density wave subsided as well. Velocity increased. And the BZ has been more variable since that moment. KP index currently at 2. It's a measurement of global geomagnetism. Each bar represents 3 hours. And you can see that brief period of geomagnetic unrest. Here's 4 hours of data of geospace magnetosphere movie. And we're expecting a pretty homogeneous pressure here over the past 4 hours, as there have not been any major changes in the solar wind. We show that data daily. And we'll also show ground magnetic perturbations here, changes to Earth's B field, otherwise known as geospace delta B. And we see some perturbations here south of the Atlantic Ocean, south of South America, as well as creeping into the southern Indian Ocean. The southern ocean here, south of Australia. That's about where the south magnetic pole is located. Here's a diagram of the solar system. Again, today is equinox day, when the Earth's equator crosses the sun's equator. Let's advance the solar system 1 week. There's where we expect things to be in a week. No, planetary alignments don't do jack to the sun. That's hilarious. The observations don't support that hypothesis, folks. Next, looking at in-the-sky.org, we've drawn in the ecliptic and the galactic plane for what's going on above my head. The moon is in a setting mode at the moment. It's a gibbous waning. And Betelgeuse is up there in the sky. Yeah, Orion's belt buckle points right toward Betelgeuse. Did you know that? Yeah, the belt. The belt creates a perpendicular line to the largest single object visible to the naked eye, the red supergiant Betelgeuse. Today's cosmology segment will be brief and integrated to this video. Check our playlists for others. And today's video's got this great equinox on a spinning Earth content here. So what happens is the day-night terminator becomes vertical at an equinox. And that's why the astronomy picture of the day is showing this time-lapse photography from a geosynchronous satellite. So that's what the equinox looks like, approximately. The day-night terminator becomes vertical, and day and night become rather equalized across the planet. It happens at 3:20 today. What will you do with your final hours of summer? Let us know in the comments. Let me press refresh as my countdown timer stopped counting down. We will be streaming live at that moment later this afternoon in 10 hours and 18 minutes. We'll be starting at about 2 p.m. That's today's cosmology segment. Again, check our playlist. There's all kinds of videos on the channel besides daily space weather. We do see some minor charging hazards here over the Caribbean, northern South America, Central America, and southern Mexico, about to move into the Central Pacific Ocean. Here's the one-year chart of electron flux. Relativistic electrons around planet Earth are at a quite low level here, as we typically see with coronal hole wind streams. And expecting an uptick here in between coronal hole wind streams. There's also a coronal mass ejection about to strike. Early in the day tomorrow is my guess. Anyway, there's the electron flux over the past 3 days. Here's the electron forecast model. I would tend to agree with this, although there's going to be a dip here when the coronal mass ejection strikes. In any case, no arguments with the forecast model at the moment. Here's a diagram of Earth Van Allen belts. Distances are shown in miles to introduce our next slide, the total electron content forecast. This gives you an idea of where GPS errors are most likely to occur, which is typically around the equator at noon. This shows anomalies. We don't see any anomalies currently. Things are looking pretty organized there. Here's another diagram of the atmosphere to show you where the F ionosphere layer is. It's in many ways the bridge between Earth and space. So now you're looking at vibrational frequency, the ionogram in megahertz, millions of vibrations per second. And we see quite a lot of high-frequency anomalies here over places like the Pacific Ocean. Also around the South Atlantic anomaly. And we'll bring up the latest image and show the anomaly map as well. Here's the latest image. That's 9 o'clock Universal Time. Here's the anomaly map, departure from the 30-day median in megahertz. To give our newer viewers a little bit of a better idea of what's going on with anomalies in the ionosphere. High-frequency anomalies shown in blue, low-frequency anomalies shown in red. Quite a bit of anomalous ionosphere behavior at the moment, and there you can see high-frequency anomalies happening here over the Indian Ocean and Southeast Asia, making it all the way up to 14 megahertz there. It's time to do bonus features and chew bubblegum, and I'm all out of bubblegum. Were you aware that we're on BitChute? It may become our exclusive outlet for content if YouTube decides to keep stiffing us. BitChute.com/smAsho. We also stream regularly on Twitch. We streamed today's meteorology segment live to Twitch. If you didn't check it out, there's a playlist for it. YouTube.com/smAsho/playlists. Thanks to our BitChute subscribers. Thanks to our patrons. Please cancel your membership by October 1st, before October 1st preferably, and sign up for the Smash team. Press like and subscribe if you enjoy the content on YouTube. I don't know why I'm even telling you this. I have to keep acting like I care. So make sure you visit our own websites, like smashomash.com, smashomash.com/smash team, etc. We're showing all kinds of information that you have to pay to see. And Smashtember is almost over. So unless you're a paid-up member, like a silver or a gold or a paid-up annual gold member and not a bronze member, you're missing most of the content. So, yeah, we need to be funded, and we need to welcome you to the Neo-Renaissance. So welcome to the Neo-Renaissance. Congratulations on realizing that our content exists. We sincerely hope it continues to exist in the current state that it is. Let's take a look at the El Teide ground-based observatory on the Isle of La Palma, actually. El Teide being the largest mountain in Spain. Yes, it's in the Canary Islands, folks. Anyway, there is the latest hydrogen alpha imagery from El Teide. It's only about 4.5 minutes old when we recorded the video. Solar flare watch remains in effect. Let's press refresh again here, just to make sure that you see that we've got the latest refreshes. It's refreshing to see people who aren't lying about science, isn't it? So I see one group, two groups. Let's count. So we've seen two in the north. I see 1, 2, 3, 4 in the south. That's 6 sunspot groups, folks. 6 sunspot groups. Here are the fields. Those are the 2 most significant groups. That one's actually been growing a bit also. Likelihood of flares from that one is still there. Let's close things out with some more imagery of the closest star. This is 304 and 171 angstroms. And we'll also show the northern and southern hemispheres in these composite wavelengths. So once again, congratulations on realizing that the channel exists. We hope it continues to exist. The likelihood of that continues to drop. The likelihood of these videos remaining free and publicly visible for all continues to drop. Please consider supporting the channel via the links below the video, such as the merch links or the Smash team. We've replaced Patreon with a vastly superior website, and you're all invited to check it out. Smashomash.com has the links. Smashomash.com/smash team is the site. Thanks for tuning in once again, and may that solar wind be at your back.